Number 12. A can of bolts and nuts is pushed 2 meters along an x-axis by a broom along the greasy floor of a car repair shop in a version of shuffleboard. This figure over here gives the work done on the can by the constant horizontal force from the broom versus the can's position x. The scale of the figure's vertical axis is set by Ws, which is equal to 6 joules. Letter A, what is the magnitude of that force? Letter B, if the can had initial kinetic energy of 3 joules moving in the positive direction of the x-axis, what is the kinetic energy at the end of the 2 meters? So in this case, we have a work and a displacement. You see, we have a work here, a displacement over here, and we want to find the force. So let's remember that the work is the dot product between the force and the displacement, which can be written as the magnitude of the force times the magnitude of the displacement times the cosine of the angle between them. In this case, the force points to the same direction of the displacement because the force goes along the x-axis and the movement is along the x-axis as well. So this angle over here, it's 0, and cosine of 0, the cosine of 0 is equal to 1. So in this case, the work is simply the magnitude of the force times the magnitude of the displacement. So we can isolate the magnitude of the force, which is equal to the work divided by the magnitude of the displacement. The work in this, let's take this point over here. So the work done is 6 joules. So it will be 6 over the displacement, which is 2 meters. So the force is equal to 3 newtons. So this is the force in this case. So letter B, let's see over here, letter B, if the can had an initial kinetic energy of 3 joules moving the positive direction of the x-axis, what is its kinetic energy at the end of the 2 meters? So let's remember that the change in the kinetic energy is equal to the work. So the final kinetic energy minus the initial kinetic energy is equal to the work. So let's send it to the right. So the final kinetic energy is equal to the work plus the initial kinetic energy. So the initial kinetic energy is equal to 3. So the final kinetic energy is equal to work. The work done is 6. So the work is 6. The initial kinetic energy is 3. So 6 plus 3 is equal to 9 joules. So this is the answer of letter B.